today we are discussing the topic of architecture instructions. So instructions, each and every time we are giving a program to the computer, what they perform. So it will be converted to the instruction in this for the CPU execution. So the number of operation and instructions can be executed in the CPU that will be represented in the machine instructions. So machine instructions in the form of binary code. If the particular task is completed, so each and every time we are converting the binary code into the high level language. So once the CPU can be executed the instructions only in the binary code, so but the programmer can write the program in the high level language. So automatically the high level language will be converted in the binary code with the form of instruction representation. So in this, what are the elements can be used for representing your instructions? That is operation code. That can be is representing opcode, which type of operation we are performing. The next one, source and destination operand. So which type of data can be taken and where it will be stored. That type of representation can be stored representing in the source and destination operand. So source operand address and destination operand address based on the address representation. The next one is next instruction address. It can be stored in the program counter, can verify the next level of execution. So in this, location for source and destination operand, it can be classified into three representation. One is processor register, main memory, and input output device. So once the user can view the data in the input device, that data will be stored in the main memory. After storing the data in the main memory, once we have to perform the operation on the data, it again that data will be going with processor register from the main memory. After completing the process, the data will be stored in the main memory. And if you want to represent the data to the user, automatically it will be taken from the main memory to output device. So immediate value, it will be representing the instruction. It is having the address of the operand. So in this representation of instruction, opcode having a 4 bits, an operand address can be represented in the 6-bit representation. So next one, instruction types. So the instruction types can be classified into two types. Based on the two types, one is according to the operation, another one is according to the address representation. So first of all, according to the operation, it can be classified as to three types. One is data processing, data storage, and data movement. Data processing, it can be represent the arithmetic and logical instructions, can perform the arithmetic and logical operation. Data storage, so the data will be moved from one location to another location and it will be stored in the memory representation. That is data storage. For example, instruction types can be having a move or store. Next one, data movement. Data transfer instruction. The data will be transferred from CPU to input output device or CPU to main memory. Likewise, we have to represent the data movement in the format of jump instruction. So in this jump instructions, we are having a control statement. One is test, another one is branch. Test means whether the condition is true or not. The branch instruction, after testing the instruction, it can be going with which type of instruction can be executed, represented in the branch instruction. So second part, according to the number of address, we are having a 0 address instruction, 1 address instruction, and 2 address instruction, and 3 address instruction. 0 address instructions is not having any operand value, just it will be storing the opcode. And 1 address instructions can be used for representing only one operand on the opcode value. 2 address instructions, we are having a 2 operands and opcode, and 3 address instructions can having a 3 opcode and 3 operands and 1 opcode. So in this representation, 3 address instruction, for example, add C, A, B. So in this, 2 A and B can be added. The value will be stored in C. In this 2 address instruction, A and B can be added. The value will be stored in A. So for example, so y equal to A plus B star C plus D. So first of all, we have to take the pre-address register. So this is a instruction representation for this expression. A and B, addition of A and B can be stored in R1, addition of C and D can be stored in R2, and finally multiply R1 and R2 and it will be stored in Y. So if you're having two address registers, so first of all, we have to move the data value to the register and then we can add these two values. So in this representation, again, each and every time we have to perform the move condition for storing the data from main memory to register. Compare with three address register and two address register, the coding path will be having a more instruction. Compare with one address instruction, it having a little bit having condition of store. Each and every time we are calculating and store the data, and then we can take the data from the main memory and we can perform the next type of instruction. But in two address register, it automatically store the data in the data memory, but one address register, it does not taking automatic storage. It will be performed with the help of store representation. So next one, types of operands. So we are having a operand A plus B. So in this, A and B is a operand and plus is a operator. So in this, we are having a two types of operand value. So that is only based on the address. And the next one is based on the data value. So if you're having an address, so whatever the data is not worry, just we have to mention the address of the data. So it will be holding the whole data with the help of the address location. So if you are representing data representation, we are having so many different types of data representation. That is number, character. So number is a addition representation. Character is a ASCII code. So we are having ASCII code is a alphabetic representation. So each and every time we are giving A to Z, it will be converted to the ASCII values for the calculations. So next one, logical data. So logical data, we are having a zeros and ones. Zero means false and one is true. The next one, types of operations. So types of operations in the data transfer operation: move, store, load, exchange, clear, set, push, pop. So these are the data transfer operation. Move, it is used to move the data from source to destination, and store is used for storing the data to the memory. Load is a memory to processor. Exchange is swapping of two data from source to destination. Clear, it will be starting from 0 to destination. It will be clear all the data. Set means it will be setting the value of 1 to the destination. Push is used for stack representation. Push and will be pop will be used in the stack representation. So next one, arithmetic operation is addition, subtraction, multiplication, division, absolute, negate, increment, decrement. All those things will be represented in the arithmetic operation. The logical operations and or not, compare, logical shift, arithmetic shift, rotate, all the operations will be performed as a logical operations. So these are the basic representation of your instructions. So mainly we are having an instruction is a set of coding that can be executed for calculating some representation of data. So in this, what are the elements can be used and what are the different types of instructions? So instruction types can be classified into based on the data movement. Another one is used based on the address representation.